Hello guys, welcome back to Math Zone. In this video, we are going to discuss some past papers about trigonometry. Let's look at the first question. It is given that alpha equals to cos inverse 8 over 17. So this is what we know, alpha, equals to cos inverse 8 over 17. Without using calculator, we want to find the exact value of 1 over sine alpha plus 1 over tangent alpha. So we need the value of sine alpha and tangent alpha. So guys, this is what we know. So we can write down cos alpha equals to 8 over 17 based on the definition of inverse trigonometry function. And then because here we have the value of cos alpha in fraction, we can use Sohcah-Toa formula, guys. Go back to our basic formula of sine, cosine, and tangent. We can use Sohcah-Toa. So we have cosine here, so we can use the formula of cosine. So cosine alpha equals to adjacent over hypotenuse. So that equals to 8 over 17. So from here we get adjacent is 18, hypotenuse is 17. So we can draw right angle triangle because Sohcah-Toa only works for right angle triangle. And then we can put alpha anywhere, here or here. I will choose here. And then we know that the adjacent value is 8. So it's here. And hypotenuse is 17. Now we can find the value of our opposite side. So we can use Pythagoras, which is square root of 17 square minus 8 square equals to square root of 289 minus 64, which is equals to square root of 225, which is equals to 15. Now, because we want to find the value of sine alpha, use the SOH formula, which is sine alpha equals to opposite divided by hypotenuse. So the opposite is 15, the one that already found before, and hypotenuse is 17. We can also find the tangent alpha using Toa formula. So tangent alpha equals to opposite divided by adjacent. So opposite is 15, adjacent is 8. So now we have the value of sine alpha and tangent alpha. Because we want to find the value of 1 over sine alpha plus 1 over tangent alpha, because our sine alpha is 15 over 17 plus 1 over tangent alpha is 15 over 8. So we can swap, become 17 plus 15 plus 8 over 15. Now you can add, you will get 25 over 15. Because we want the exact value, so leave your answer in fraction, which is 5 over 3. Okay guys, let's move on to the next question. Here we have a curve has equation y equals to 2 plus 3 sine half x, for x is in between 0 until 4 pi. Now, the first question is state the greatest and least values of y. So, if you still remember, the general form of sine x is a sine bx minus c plus d. Now, as we can see, we have a is coefficient of sine, which is a equals to 3. B is a number in front of x, which is half. We don't have c, so as you can see, we don't have minus something or plus something here. So 0 means that there is no horizontal translation, and the d is 2 because you have plus 2 here. Now, if you want to know the greatest and least values of y, we can use this formula. To find the greatest value, you just need to add d plus a, or you add 2 plus 3, which is equals to 5. The least will be d minus a, which is 2 minus 3 minus 1. So you can memorize this formula, or the logic here is, we know that sine x, the maximum is 1, the minimum is negative 1 for sine x, or half x, also same thing. The maximum is 1, minimum is negative 1. So for the greatest, you can substitute y equals to 2 plus 3. The sine x will become 1 because you want to find the greatest. So you will get 5. The minimum, you just make the sign negative 1, so you will get negative 1. So you can use this concept or the formula, up to you. Same thing. Now, let's sketch the curve. We already know that the a value is 3, means that it is the amplitude, but to draw the sine function, we have to start from the principal axis, which is d equals to 2. So principal axis is like the middle part of the graph. So let me draw the value first. Okay, so first thing first, we draw the principal axis, which is the middle part of the graph. We can take a dash line, because it is not part of the graph. And after that, because we know that sine x, for sine value, start from 0, 0, as long as there is no horizontal translation. Just remember, for sine x, it always start from 0, 0, but because our principal axis is at y equals to 2, so we can start from here. Start from 0 and start from the principal axis, and then you go up. If you have horizontal translation, you have to move your starting point, so be careful. For sine, always start from the principal axis here, and then the x equals to 0, and then you go up by the amplitude is 3, right? But we have to know the period. The period formula is 2 pi over b. So 2 pi over half, which is 4 pi. So that means the period will be until 4 pi. So 4 pi is 1 wave. So that means half the wave, 2 pi. So you draw half the wave, so it's like from here to here, and you make the hill, because 1 wave is like the hill. So in between, which is pi, is like the peak. So approximately like this, it's at 5, and then you go down. So the peak happens at 1 over 4 the period. Now we just need to draw the value. We already calculate the least value is -1, so this is -1 around here, and then the minimum happens at 3 pi, like the middle, so it's here, the bottom part of the graph. So you just draw a value and stop at 4 pi, so approximately like this. So this is your curve. You need to know the amplitude, which is 3. You need to know the principal axis. You need to know the starting point, always from x equals to 0 and at the principal axis. And you have to know the maximum and minimum value. Go down also 3. That's why to find the maximum point, this is d, this is a, this is minus a, because go down, right? So you just need to d plus a, you get 5, d minus a, you get -1. State the number of solutions of the equation 2 plus 3 sine half x equals to 5 minus 2x. Now, because we want to find the number of solution, we don't want to find the solution, but just number of solution. You can know it from the intersection between the graph and the line. So first thing first, let's draw a line, which is 5 minus 2x. So let's draw y equals to 5 minus 2x. So we can find the x-intercept, y equals to 0. We get x equals to 5 over 2 or 2.5. And then y-intercept, x is equals to 0. So y equals to, substitute x to 0, y equals to 5. So let's see here. Y equals to 5, so it's here. Yeah, so that will intersect at this point, 0, 5. And x is 2.5 and 0. So we don't know where is 2.5 exactly, but we know that pi is approximately 3.14. So maybe it's around here. Yeah, and you take a straight line that passing through these 2 points. Now, as you can see, it only intersect at 1 point. So the answer is 1. Okay guys, move on to the next question. Now I have the graph. We are asked to find the function. So here we have the function, the graph, and the function is y equals to p sine q theta plus r. So theta is like the x. Now we need to find the value of p, the value of q, and the value of r. Okay, first thing first, what is p? P is a coefficient of sine x, so p is the amplitude. How do you find amplitude? It is the distance from the principal axis, which is the middle part of the graph, to the peak of the function, because the graph starts from -2 to 1, so the height is 3. So p equals to 3. Now, how to find q? Q is related to the period, because we know the formula is period. For the sine is 2 pi over q. So we can find q, just divide 2 pi with the period. And the period is the horizontal distance for one full wave, which is from 0 to 4 pi. You have one hill and one valley. So from 0 to 4 pi. So 2 pi over 4 pi. 1 over 2. That's the value of q. And the value of r, simple. The value of r is the principal axis. As you can see, principal axis is at -2. So the r value will be -2. So this is how you find PQR. Okay guys, move on to the next question. Here we have the diagram. Shows part of the graph of the transform tangent x now. So here we have the graph, and we have the function a tangent x minus b plus c, and we want to find the value of a, b, and c. So first thing first, let's see the transform one. Okay, this is like x minus something. This something is the horizontal shift. The c is the principal axis or vertical shift, or the vertical shift, and a is not amplitude. Yeah, it's just determine the shape of the tangent. It's very tricky how to find a. Let's see later, but let's find b and c first. Okay, as we know that first thing first, the easiest one, we can find the principal axis, which is the middle part of the graph. The middle part of the graph is like changes the curvature of the graph. If you see here, this is like the graph. It start to goes up here. It increases, the gradient increases. So this one, the gradient decreases until this point. Now it changes, the graph now goes up rapidly. So this point is the middle part of the graph, so we can say that this is our middle middle line. We call it as principal axis is at equals to 1. So the c value equals to 1. Now, how to find b? B is the horizontal shift. We know that the horizontal shift for the normal tangent, it starts from 0, 0. Start from 0, 0. And we already move it up by vertical shift here. and then the starting point is being translated to this. In the y equals to tangent x, the starting point is like the boundary between these two curves. So this is like the middle point. The middle point is the starting point in the y equals to tangent x, supposed to be here, but we move it up by 1 unit and we move it up by 1 over 4 pi. So the answer is b equals to 1 over 4 pi. Now, to find the value of a, we need to substitute the value. So first we need to find a value, a good one. Let's say I choose this value, 1 over 2 pi, and this is the coordinate, so 1 over 2 pi comma 3. So we can substitute this point to find the a. So we get y equals to a tangent x minus b plus c. So a tangent x minus b is 1 over 4 pi plus 1. We substitute the value of coordinate that we have, 1 over 2 pi and 3. So we substitute y equals to 3. A tangent x is 1 over 2 pi minus 1 over 4 pi plus 1. So we can subtract both sides by 1. 2 equals to a tangent 1 over 4 pi. And we know that tangent 1 over 4 pi is the same thing as tangent 45 degree. And tangent 45 degree, you can use sine over cos if you don't know the value. Or you can use calculator, yeah, to find tangent 45 degree, yeah. If you use manual way, you get 1 over 2 square root of 2 over 1 over 2 square root of 2. You will get a equals to 2. Or if you use calculator to find tangent 45 degree or tangent 1 over 4 pi, you will get 2 equals to a times 1, so a equals to 2. So here we have a equals to 2, b equals to 1 over 4 pi, and c equals to 1. Okay guys, move on to the next question. Here we have part of the graph where fx equals to 3 plus 2 sine 1 over 4x, for x is in between 0 until 2 pi. The first question is, on the diagram above, sketch the graph of y equals to f inverse x. So how do we draw the f inverse x if we have fx? So first thing first, you have to draw y equals to x line. So we know that y equals to x means that the value of x will be the same as the value of y. So we have 0, 0 and 2 pi until 2 pi, because the value must be same, y equals to x. And then you take a straight line from 0, 0 until 2 pi. So this is the first step. You need to draw line y equals to x. Why is that? Because the graph of f inverse x will be the reflection in the line y equals to x. So after that, as we see that the starting point is approximately less than pi a little bit, so this is the y value, we make it becomes x value, so starting from here approximately, and then make it kind of like reflection, and we'll intersect here. So the fx and f inverse x will intersect here at the line y equals to x. That's one of the characteristics. And then it will stop here around more than 3 over 2 pi. So it stops here approximately more than 3 over 2 pi. We change it from y value becomes x value. That's the inverse. So we just need to sketch a graph approximately like this. Which may like here. Okay, it's very hard, so let me use manual. So okay, let me do it better. So maybe it's from here to here approximately, yeah, and then we draw it like this. So this is the y equals to f inverse x. You get 2 marks. The first mark for drawing this, second mark for drawing this, and correct points approximately, and intersect here at the line y equals to x. The second one, find an expression for f inverse x. So let's recall your mind, how do we find inverse function? First thing first, you have to make fx equals to y. The second one, we have to interchange x and y. The third one, you solve for y. And the fourth one, you make y equals to f inverse x. So let's start from the first one. We change fx equals to y. So y equals to 3 plus 2 sine 1 over 4x. And then we interchange x and y for the second step. First step done. Second step, we interchange x and y. And then the third step, solve for y. So how do we solve for y? Let's see here. We can isolate the y, so we can subtract both sides by 3. So x minus 3 equals to 2 sine 1 over 4y. And then we divide both sides by 2. You will get, I'll move sine 1 over 4y here, equals to x minus 3 over 2. Now, because we want to isolate y, we need to get rid of sine x. How you do that? We use the sine inverse concept. So 1 over 4y equals to sine inverse of the right hand side. And then to get y, you just need to multiply by 4 both sides. You will get 4 sine inverse x minus 3 over 2. So this is the expression for f inverse x. 4 sine inverse x minus 3 over 2. So this is the answer. Okay guys, part C. Here we have the diagram above shows part of the graph of the function gx equals to 3 plus 2 sine 1 over 4x, which is the previous function, similar, but now we extend the domain from minus 2 pi until 2 pi. So this is the graph. The first one, complete the sketch of the graph of gx, because in the graph it only it starts from 0, but our domain starts from minus 2 pi, so we need to complete the left part of the graph. And then explain whether the function g has an inverse. Okay, so let's see what we have here. First thing first, we know that the gx, we have the principal axis is at 3. So if you look at the graph starts from here, which is approximately 3, because pi is like 3.14. So it starts from the principal axis here and then goes up. Now let's recall that for the sine function, this is the y-axis, this is the principal axis. The graph must start from here, from the y-axis and the principal axis, the intersection, and then it goes up to the right and goes down to the left. So it's kind of like this. This happens as long as you don't have horizontal shift, because if you have horizontal shift, you have to move this left or right, but we don't have horizontal shift because there is no plus minus inside the sign here. Okay, and then you just need to draw exactly similar to this but opposite. It ends at 2 pi, so we have to start from minus 2 pi, and at 2 pi, let's approximate, it's like more than 2 boxes, 2 boxes and more. So we can draw more than 2 boxes and more. Approximately it's like this. Okay, this one more than 2 boxes approximately. So this is the continuation of the graph. It creates a sine wave. The graph kind of like this. Explain whether the function g has an inverse. G has an inverse because gx is a 1 function. Why is that? Because if you look at the graph, it passes through the horizontal line test. Whatever horizontal line you put there, it always gives you one intersection. So the answer is gx is a 1 function. That means gx has an inverse. The last question, describe a fully sequence of 3 transformations which can be combined to transform the graph of y equals to sine x. So this is our original function to the graph of y equals to fx. What is y equals to fx? This one. 3 plus 2 sine 1 over 4x. So we want to transform it into y equals to it's the same as gx, just different domain. 3 plus 2 sine 1 over 4x, making clear the order in which the transformations are applied. So first thing first, we have sine x, but here we have sine 1 over 4x. So the first transformation is we need to change from sine x into sine 1 over 4x. You do that by doing horizontal stretch. Horizontal stretch, the factor, the scale factor is opposite, not 1 over 4 but 4. Remember, if it is horizontal stretch, the factor will be 1 over this, or the opposite over 4. That means the factor is 4 times. That applies to horizontal transformation. And after that, from sine 1 over 4x, you want to multiply it by 2. So we have to do 2 times sine 1 over 4x, which is the vertical stretch. Because we multiply the whole thing by 2, so vertical stretch, sorry, typo, vertical stretch by factor 2. Yeah, it's not 1 over 2 because it's vertical. Vertical, just take the number. And from 2 sine 1 over 4x, we have to add by 3 the whole thing. So that means we need to do the translation. Vertical translation, yeah, by vector 0, 3. Means that we move it up by 3 units, but we don't do any horizontal translation. So the answer is, the first one is horizontal stretch, or you can say horizontal in x direction by factor 4. The second one is horizontal stretch. Yeah, I forgot to put stretch. Second one is vertical stretch in y direction, or you can say vertical stretch by factor 2. And then the third one, you say vertical translation by vector 0, 3. So this is the order. Okay guys, let's move on to the next question, which is about calculation problems. So here we have the first question, AI. By first expanding cos theta plus sin theta and then square, find the 3 solutions of the equation cos theta plus sin theta square plus 1, so equals to 1, for theta is in between 0 until pi. So we are given a clue. We need to expand the cos theta plus sin theta and then square. So here we have cos theta plus sin theta square. How do we expand this? We know in the algebra formula we have a plus b square equals to a square plus 2ab plus b square. So we can apply for cos theta plus sin theta. So it gives you cos. Yeah, the a is cos, b is sin. So it equals to a square, or cosine square theta, plus 2ab, 2 times cos theta times sin theta, plus sin square theta, and this will be equals to 1 because the question tells us it equals to 1. Okay, how do we simplify this? We have the second formula in the trigonometry that says cos square theta plus sine square theta equals to 1. So whenever in the question you have cos square and sine square added, just make it equals to 1. That's the key. So you will get 2 cos theta sine theta plus 1. Yeah, whenever you find cos square plus sine square becomes 1 equals to 1. So now we have 2 cos theta sine theta equals to 0. Now, the next question is how do we solve for theta? From here, because it's like multiplication of 2 times cos theta times sine theta equals to 0, how to make it 0? We have 2 ways. Either the cos theta that is 0, so 2 times 0 times sine theta equals to 0, or make sine theta equals to 0 because 2 times cos theta times 0 equals to 0. So either cos theta equals to 0 or sine theta equals to 0. It's like factorization. Yeah, same thing. Okay, from here, how do we know the value of theta equals cos theta equals to 0 and sine theta equals to 0? First thing first, you have to look at the domain. It's in between 0 until pi. And then you need to find the value of theta. The easiest way, usually I use a unit circle. Unit circle is a circle with center 0, 0 and radius 1. So by using unit circle, we know that the coordinates of the point on the circle will be cos theta and sine theta. You should remember that for the unit circle. So because we want to make cos theta equals to 0, so at what point cos theta is the x coordinate? So make x coordinate equals to 0. We have 2 points. This one 0, 1 and this one 0, -1. But our domain only stop until pi. So pi is like half the circle. So we have to erase the other half of the circle. We don't care about what happened after pi. So it's like 0 degree. This is pi. So we only have one coordinate. Sorry. Okay, and that gives you the angle is 90 degree. So theta will be 90 degree, or we change it into radian, pi over 2. Or if you don't know how to do this, you can use theta equals to cos inverse 0, and the calculator will give us pi over 2 as well. As long as your calculator is in radian mode, you can use calculator as well. But for sine, let's see, for sine is the y coordinate, which is 0. So that happens here, 1, 0 and -1, 0. So as you can see, it happens here and here. It happens at 0 degree and pi. 0 degree and pi, or 180 degree. So theta will be equals to 0 or equals to pi. Or if you use calculator, you can use the sine inverse, but you only get one value, which is 0. To get the second value, which is pi, you have to draw the unit circle. So we have to three answer: pi over 2, 0 or pi. And that these are the three solutions of the equation, either 0, pi or pi over 2. The second one, hence verify that the only solution of the equation cos theta plus sine theta equals to 1 for theta is in between 0 until pi, are 0 and 1 over 2 pi. So from the previous equation, we already proved that cos theta plus sine theta square equals to 1. That makes our cos theta plus sin theta will be equals to plus minus 1, right? So there are two options, either cos theta plus sin theta equals to 1 or cos theta plus sin theta equals to negative 1. Now, to verify that the only solution only 0 and 1 over 2 pi, and we know that the solution for this is 0, 1 over 2 pi, and pi. So we need to substitute this solution to know that where it belongs, to this one or to this one. So let's substitute theta equals to 0, substitute to our equation, which is cos theta plus sin theta, which is equals to cos 0 plus sin 0. Cos 0, we know that equals to 1, plus sin 0 equals to 0. So it equals to 1, which is satisfy our equation. It must be equals to 1, not negative 1. So this is like our goal here. So that means the theta equals to 0 belongs to this one. For theta equals to pi over 2 or 90 degree, you substitute cos pi over 2 plus sin pi over 2 equals to cos pi over 2 cos 90 degree is 0 plus sin 90 is 1. So 0 plus 1 is 1, which is also equals to 1, belongs to the first category. So 0 and 1 over 2 pi belongs to this. But the last one, theta equals to pi, if you substitute cos pi plus sin pi, cos pi, if you look at the unit circle here, it equals to negative 1. And the sign is 0. So that gives you minus 1 plus 0. That equals to negative 1, which is not the one that we are looking for, because we are looking for equals to 1, not equals to this. So the only solution, only 0 and pi over 2. Now, let's move on to the part B. This is trigonometry proving identity. We have this sin theta over cos theta plus sin theta plus 1 minus cos theta over cos theta minus sin theta is equivalent to cos theta plus sin theta minus 1 over 1 minus 2 sin square theta. Okay, if the paper gives you this type of question, we have left hand side and right hand side. So our method to prove the identity is, from left hand side you have to change it into right hand side by using formulas, or you can do either way. From right hand side, use the formula to change it to left hand side. But my suggestion is always start from the most complex one, and we know that left hand side is more complex because it's easier to make something complex, make it simpler, instead of from simpler one make it more complex. It's harder. So start from the most complex one, which is left hand side. Sin theta over cos theta plus sin theta equals plus 1 minus cos theta over cos theta minus sin theta. Now we want to change it into this. How do we do that? The first trick is combine the fraction. If you have two separate fractions, you have to combine the fractions. This is one of the tricks. Because we have separated fractions here, we can make the denominator equal. So we can change it into cos theta plus sin theta multiplied by cos theta minus sin theta. And then this thing divide by this and then multiply by sin theta. So sin theta multiplied by this. So we will get sin theta times cos theta minus sin theta plus 1 minus cos times with this 1 minus cos theta multiplied by cos theta plus sin theta. Nah, it's kind of long. So if you look at the bottom part, it's kind of familiar because we have a plus b times a minus b equals to a square minus b square, right? So the bottom part will gives us a square minus b square. So cos square theta minus sine square theta, a plus b, a minus b, a square minus b square. And then the top part is kind of messy, so maybe we can expand first and hope that it can be simpler. So sine theta times cos theta minus sine square theta plus 1 times cos theta become cos theta, 1 times sine theta becomes sine theta, minus cos theta times cos theta become minus cos square theta, and then minus cos theta times sine theta becomes minus sine theta cos theta. Is it simpler? Yes, because we can cancel sine theta cos theta with minus sine theta cos theta. Now, let's look our goal here. Our goal here, at the bottom, we don't have cos theta. We only have sine theta, but how do we change cos square becomes sine square? There is one formula, which is cos square theta plus sine square theta equals to 1. Because we only want sine theta in at the bottom here, so we can substitute cos square theta equals to 1 minus sine square theta. So we can substitute here, cos square theta becomes 1 minus sine square theta minus sine square theta. And then here, the top part, we already have cos theta plus sine theta, so we don't need to change it. But here, instead of having minus sine square minus cos square, we have minus 1. So we have to change it into that. How do we do that? We can take out the minus in the bracket, sine square theta plus cos square theta, and we have plus the blue one, cos theta plus sine theta. Why we do that? Because we know that sine square plus cos square equals to 1. So this becomes minus 1. So it can be simplified into cos theta plus sine theta minus, this one becomes 1 over 1 minus, you have minus sine square becomes minus 2 sine square theta. So this is the answer. So the tips is combine fractions and then expand. You can expand and then you can utilize this formula. You can substitute cos square, you can substitute sine square, but depends on what you need. You have to refer to the goal, which is the right hand side. Okay guys, in part C, we are asked to use the result of AII and B to solve the equation sine theta over cos theta plus sine theta plus 1 minus cos theta over cos theta minus sine theta equals to 2 times cos theta sine theta minus 1. For theta is in between 0 and pi. So if you look closely, we are asked to use result from part B and result from part B. As you see, this, the left hand side, is the same thing as the left hand side in part C. So we can make it equals to right hand side because we already proved it. So we can replace this with the result from part B. So the equation will change into cos theta plus sine theta minus 1 over 1 minus 2 sine square theta. This is from the result from part B. And we make it equals to 2 times cos theta plus sine theta minus 1. We replace it with this. Okay, from here we can multiply both sides by 1 minus 2 sine square theta. You will get cos theta plus sine theta minus 1 equals to 1 minus 2 sine square theta times 2 cos theta plus sine theta minus 1. Sorry, 2 is outside, so it has to be like this. Okay, now what do we do with this complicated thing? If you want to expand, for sure, but that will be like make things more complicated. Should see the pattern here. There's like a similar term. Yeah, maybe we can change it to the move it all, so it becomes 1 minus 2 sine square theta. Let me put 2 here, times cos theta plus sine theta minus 1 minus, so we move it here, cos theta plus sine theta minus 1 equals to 0. Now we can factorize the cos theta plus sine theta minus 1. Okay, so we will get cos theta plus sine theta minus 1. We take it out, and then we have the rest. 2 times 1 minus 2 sine square theta minus, this is we have 1, so minus 1 equals to 0. Now from here we just need to factorize the first one. The first one is cos theta plus sine theta minus 1 equals to 0. It's like factorization. So we get cos theta plus sine theta equals to 1. So from here we get two answer, either 0 or pi over 2. It's based on AI result from the previous one. Yeah, same thing. The second one, we need to solve it. 2 times 1 minus 2 sine square theta minus 1 equals to 0. So that gives us 1 minus 2 sine square theta equals to 1. So 1 minus 2 sine square theta equals to 1 over 2. Oh, very hard to read. Let me move it first. 1 minus 2 sine square theta equals to 1 over 2. We divide both sides by 2. From here, we get 1 minus half equals to 2 sine square theta. So 2 sine square theta equals to half. Sine square theta equals to 1 over 4. So sine theta is plus 1 over 2 or minus square root of 2, because from here we can say sine theta equals to plus minus 1 over 2. But if you see the domain is from 0 to pi, which is only includes the first and the second quadrant, and the first and second quadrant, the sign value always be positive, so we don't take the negative version. We just care about sine theta equals to half. From the first quadrant, we get theta equals to sine inverse half. You can use calculator to gives you 30 degree or pi over 6. And the second quadrant, you can use the basic angle. Our basic angle is pi over 6. And what is our angle? So this is our basic angle, 30 degree. So the next angle is 150 degree or 150 degree or 5 pi over 6, because it's just pi minus pi over 6. 180 degree minus 30 degree, you get 5 pi over 6. So we have 4 solution for this: 0, pi over 2, pi over 6, 5 pi over 6. So this is the answer. Okay guys, let's move on to the next question. This question is combining the quadratic equation with the trigonometry. So let's try to solve it. The first one, we are asked to solve the equation 6 square root of y plus 2 over square root of y minus 7 equals to 0. So how do we solve this quadratic equation? We have to multiply both sides by square root of y to eliminate the square root of y at the bottom or denominator. So we will get 6y plus 2 minus 7 square root of y equals to 0. From here, how do we solve the quadratic? You can let u equals to square root of y. So u square equals to y. So we substitute 6u square plus 2 minus 7u equals to 0. Here we get 6u square minus 7u plus 2 equals to 0. From here, we have a is 6, c is 2. So we multiply to get 12. To get minus 7, you have to factorize it into minus 4 minus 3. So we have 6u square minus 4u minus 3u plus 2 equals to 0. We take out the 2u in the bracket, 3u minus 2, and we take out the negative, becomes 3u negative 2 equals to 0. So we get 2u minus 1 times 3u minus 2 equals to 0. So the first one, we have u equals to half or u equals to 2 over 3. But we want to solve for y. So we have to replace it with square root of y. So u equals to square root of y equals to half or 2 over 3. So we get y equals to 1 over 4 or y equals to 2 over, we 4 over 9. We square it. Okay, the second one, we need to solve the equation 6 square root of tangent x plus 2 square root of tangent x minus 7 equals to 0 for x is in between 0 and 360 degree. If you look at the pattern, this is part A. Equation is exactly the same if we replace y with tangent x. So by replacing y equals to tangent x, part B problem become part A problem, and we already got the solution, which is y equals to 1 over 4 or y equals to 4 over 9. So we can replace y with tangent x to solve for x now. Tangent x equals to 1 over 4 or tangent x equals to 4 over 9. Because our domain lies between 0 until 360 degree, which includes the first quadrant until the fourth quadrant, and our tangent value is positive, means that we can get to solution, which is from the first quadrant and the third quadrant. The first quadrant, you can get it from using calculator. Tangent inverse 1 over 4. Let me use calculator first. You will get 14.0 degree. Usually we use 1 decimal place for degree. For the third quadrant solution, we make our first quadrant value becomes basic angle, and the basic angle for the third quadrant 14 degrees, so approximately this. So our next angle is 180 degree plus 14 degree. So our next x value will be 180 degree plus 14 degree. You will get 194.0 degree. This one, you can also find the first quadrant solution, x equals to tangent inverse of 4 over 9. Use your calculator to get the value of x, which is 23.96. Round off to 1 decimal place, 24.0. The third quadrant solution, do the same thing. You just add with 180 degree. And then you will get it equals to 204.0 degree. So now we have for solution for our equation. Okay guys, let's do the last question in the video. The first one, show that the equation 3 tangent square x minus 3 sine square x minus 4 equals to 0 may be expressed in the form of a cos 4x plus b cos square x plus c equals to 0, where a, b, c are constant to be found. So we are asked to change the tangent, the sine, into all cosine. So how we do that? First thing first, we have the formula to change tangent into cos, which is sine x over cos x. Because we have tangent square, we just need to square the sine and the cos. So we get 3 times sine square x over cos square x minus 3 sine square x minus 4 equals to 0. And then we eliminate the denominator by multiplying both sides by cos square x. So we will get 3 sine square x minus 3 sine square x cos square x minus 4 cos square x equals to 0. Now, our goal only contain cos. We don't have sine. So how to change sine square into cos form? We have the formula, which is sine square x plus cos square x equals to 1, right? So we have sine square x equals to 1 minus cos square x. So these two formula is the one that we always use to do the trigonometry identity. So we can replace 1 minus cos square x minus 3 times 1 minus cos square x times cos square x minus 4 cos square x equals to 0. From here, we can expand 3 minus cos square x minus, we expand this with this first, yeah, become cos square x minus cos 4x, x minus 4 I mean, minus 4 cos square x equals to 0. We expand again, 3 minus, sorry, this one's supposed to be 3 minus 3 cos square x minus 3 cos square x plus 3 cos exponent 4x minus 4 cos square x equals to 0. Now we have the first one, which is cos exponent 4x, and then we have the cos square minus 3 and minus 4 becomes minus 10 cos square x plus the last one is 3 equals to 0. So this is our ABC constant to be found. Already A is 3, B is minus 10, and C is equals to 3. The next one, we are asked to solve the equation for x is in between 0 until 180 degree. As you can see, this one is exactly the same thing as this. So we can change it into this form because we already proved it is correct. So we can change it into 3 cos exponent 4x minus 10 cos square x plus 3 equals to 0. The same thing because we already changed it into this form. Okay, now how to solve this? We can let u equals to cos square x. So we will get 3u square because u square is cos x minus 4 x minus 10u plus 3 equals to 0. And then this is like 3 times 3 becomes 9, and then we can have minus 9 times minus 1 to get minus 10. So 3u square minus 9u minus u plus 3 equals to 0. From here we can take out the 3u, becomes u minus 3 minus in the bracket u minus 3 equals to 0. So the first one is 3u minus 1, the second one is u minus 3 equals to 0. So from here we get u equals to 1 over 3 or the second one u equals to 3. But we already substitute u is cos square x, so cos square x equals to 1 over 3. So cos x equals to plus minus 1 over square root of 3. And the second one is cos square x equals to 3, so cos x equals to plus minus square root of 3. Now, how to find x? Let's see the domain first. The domain from 0 to 180 degree, it only includes first quadrant and second quadrant. So the first one, cos is equals to 1 over square root of 3. The second one, cos is minus 1 over square root of 3. Because our quadrant only the first and the second, in the first cosine is positive, the second cosine is negative. So the first one, because our cosine is positive, it lies on the first quadrant, which we can find it using our calculator. Cos inverse 1 over square root of 3. So we get cos inverse 1 over square root of 3. So we get 54.7 degree. The second one is cos x equals to minus 1 over square root of 3. As we know that minus means that it lies on the second quadrant, so we can make our basic angle equals to 54.7. So this is our quadrant, second quadrant, so like maybe here, this is 54.7. So the angle that we want to find is 180 degree minus 54.7. So our x will be 180 degree minus 54.7, and that gives you 125.3 degree. How about the second one? This one is impossible because we know that the cos x, the maximum is 1, the minimum is negative 1, so the domain always lies between minus 1 and 1. But square root of 3 is approximately plus minus 1.71, so it's beyond our range. Or if you use calculator, x equals to cos inverse square root of 3, that will give you math error because it's out of the range. And that also same for minus square root of 3, that also gives you math error. So the answer only 2, which is 54.7 and 125.3. Thank you guys for watching this video. I hope this can help you in doing math. Thank you guys.